Hi everybody. In this video, we're going to have a look at question 2 on the 2022 higher level paper, and it's from section A, the experiment questions, and it's on Boyle's law. Okay, so we're going to have a look, just read through the question as if we were in an exam and get a feel for it. In section A, traditionally it was you have 4 questions and you needed to do 3. In 2022, because it was a year that was affected by COVID closures, etc., you had 5 questions and you needed to only do 2. Excuse me. So you always have choice. So when you're in your exam paper, you're going to take a minute to read through the questions and see what looks good for you. And that's what we're going to do here. So definitely, excuse me, sorry. If you are trying to prepare the best you can for your exam, what you need to be doing is basically pretending that you're in the exam, testing yourself, having just the question open in front of you and your piece of paper to work out the answers, and seeing how far you get with it, because that shows you what you know and what you don't know. Because it's very, very easy for you to just watch away this video and it'll all hopefully make sense when you're watching through and someone's giving you the answer. It seems fine, but when you're stuck and you're on your own, it might not be so easy. So before you continue to watch this, I would think if you want to really get the most out of it, you have your own attempt made and have that in front of you and see where you got stuck, where you didn't, where your answer might have been different to mine or not. And anywhere that you are stuck or you have a slightly different answer, send on a question and I'll let you know if I can help out, and we'll be able to figure it out, because this is an example of one answer. You might have done it slightly differently and that might be completely fine too. Okay, so here we are. We're in our exam hall. We've been given the paper and we're having a look at it to see if this is a question that we'd like to attempt. So we're going to have a read through and see what we make of it. In an experiment to verify Boyle's law, straight away telling you what experiment they're talking about, a student measured the length L of a column of air of fixed mass and a uniform diameter at different values of air pressure P. The following data were recorded. And this is very common in experiment questions. You'd be given a table with lots of data points that a theoretical student recorded from their experiment. So we've got length in the first part, and it's in centimeters. And we've got a few values that they measured across, and that's how long their column of air was. And then in the second part of that data table, we have pressure in kilopascals, and we have our pressure measurements too, which would have been measured from a pressure gauge most likely, okay? This first part is asking you to state Boyle's law. Should be something that we can do if we have our definitions learned off. There is also kind of a more mathsy way of tackling that question, and we'll look at both in just a minute. Second part, this is a very textbook experiment question. Draw a label diagram of how the apparatus was arranged in the experiment. Super. This is all stuff that we hopefully are familiar with from learning our experiments. Third part, and again, I've said this in previous videos, if they're coming in with a why, that's where they're trying to see who's really thinking about it. So why is it necessary for the column of air to have a uniform diameter? Excuse me. So whenever you see those whys, most students can take a stab at the definition and most students can draw a label diagram. But it's the ones that are really pushing for those top marks will do a good job on those why questions, all right? Why or explain, that can be it. The ones where they're looking for who's going to be up the top. Part 4, draw a suitable graph to verify Boyle's law. Nice one. Part 5, explain how your graph verifies Boyle's law. And again, if you've done this experiment and similar ones and you've done a few graphs, this is probably something that you should feel pretty comfortable with. Then it says one of the data points is inconsistent with the other data points. Which one is the first part? So which one of the data points is inconsistent with the others? And lastly, how did you treat that data point when you drew your graph? So what did you do with it when you got a set of results that we have here in the table and one of them is looking a bit weird? What did you do? They're just checking to see if you are getting the idea of it, okay? This is not a bad one. In that same paper, there was kind of a similar, or also a mechanics question 1, and I definitely would have chosen this over that. They're both fine, but this is okay. So I think this is manageable, in my opinion. Let me know if you disagree. and I think we'll just get into it and start answering your questions, okay? I'm going to give myself space. I have big writing, and I just want to give myself lots of space on my whiteboard to state Boyle's law and talk about it. As I mentioned just there, there's also kind of a mathsy way of doing it too. So I'm going to do both options. Either is fine. You should get your marks for everything. So Boyle's law is one that we should kind of know. We should definitely know, not kind of, but it makes a lot of sense, right? So Boyle's law states that at a constant temperature, the volume of a fixed mass of gas is inversely proportional to its pressure. Okay, we've got lots of sciencey words in there. Volume is how much space something takes up, and it's inversely proportional to pressure. So if your pressure, it's kind of, when you think about how your pressure and your volume are associated, if you're keeping everything else the same and you're increasing the pressure, your volume is going to change as well. So let's write the text version of it so we can just have a look at that to start, and then I'll show you the mathsy one. So you might have various different textbooks, and we might have learned off different definitions depending, but as long as they're getting the same point across, that's fine. Don't get too hung up on the exact wording. If you have one that you think looks a bit weird and you want me to cast my eye over it and see, do you like the look of it? Does it seem like something that would work? Let me know, I can. So Boyle's law states that at a constant temperature, the volume of a fixed mass of gas is inversely proportional to its pressure. Okay, let's maths that up a little bit, okay? This is fine, by the way. If you just wrote that, you're done. You got your marks. You've stated Boyle's law. But I'm just going to talk about it in a mathsy way, because you could also answer it like this. That is a proportionality sign. This little guy looks like a stretched out alpha, kind of. So pressure is proportional to 1 over volume. So this is what they mean by the inverse, the 1 over. And if you like to continue a little bit, pressure is equal to a constant. That means any fixed number. We don't know that number. We don't need to know. Just tidy it up a little bit to make it clearer for you. Constant K multiplied by 1 over V. So just so you can put in an equals, you need to put in that constant, okay? And I'll just for full correct mathsing, where K is a constant. So it's just a number that doesn't change, okay? So K is a constant. And we'll get a formula that looks a little bit like this: PV equals K. Now you don't really need to have all that for this, but it's just so you know what's going on. And this last one looks a bit more like Boyle's law, and maybe for the chemistry people as well, you might be more familiar with looking at something that looks a little bit like this. And if you're trying to link that in, and if you're chemistry, I also have a lot of chemistry, so give me a message if you want to see how that relates into your chemistry course too. But here we go. That's it. We were definition part done. We are going to now look at the next part, which is drawing the label diagram. Now, I have a sample answer, as I usually do, and in that sample answer, I have a nice diagram drawn out, and of course, there's plenty of diagrams in your textbook, and if you have your notes and all that, you'll see lots of diagrams. But I'm actually going to draw it here best I can, because I feel that sometimes I have questions from students about like the level of detail you need to have in your diagram, what parts need to be labeled, and even just to see how the diagram is built, how is it put together, sometimes makes more sense what's going on in the experiment once you've seen that, okay? Now there are variations to this, but this is a pretty standard enough one, so let's just start with it. Your question told you that you measured the length of a column of air for a fixed mass of gas with uniform diameter. You took different values of air pressure, right? So you automatically know you're going to have something measuring length and you're going to have something measuring pressure, and those are going to be an important part of your diagram, okay? So this is one where there's usually like a column, we say, of oil. Oh, they have air in this one, but we can just use the same diagram and use air. And the column is up along, I'll draw it for you. along the edge of the column, you have markings, centimeter markings, hopefully just to make it easier for you. And you'll have your column, which will be partially filled. In this case, if it's air, you might be doing something a bit different. I'll just draw my standard diagram and we'll have a chat then. This is your column, and there's some oil here, and there's air up the top here. Okay, so I think I have a mislabel on my sample answer, but have a look there now. Okay, and it's on usually something like, if your lab is a bit older, at least you'll have a piece of timber, like a meter stick, kind of fixed next to your oil gauge, and along it you'll have, let's say, centimeters. I'm going to say centimeters because they gave me centimeters in the question, so I'm just going to keep my life nice and easy and say that I've got centimeters. And you know, when you're going up like 10, 20, 30, 40, so on, excuse me, and you'll be able to just read off the level of each of these. So I'll just put some numbers just so you have an idea roughly how it looks. It's a bit hard because my pen isn't as good as I would be on pen and paper. And I'll label it when I'm finished, but what we'll have at the other side then is a pressure gauge, and they are connected. And you just have a little box. Keep it kind of simple because you won't have loads of time, and we're not, as you can probably see from my drawings, we're not all artists, so you don't want anything too complicated. There's more oil here, and you have a gauge. Now, I notice some textbooks have lots and lots of detail on their drawings. That's not kind of hard to replicate when you're in your exam. So you just want to get the basics across to your examiner and make sure that they know that you understand what's going on, okay? No. That's about all we have to draw. So let's start labeling and make sense of it. Now, this is obviously meant to be a bit flat, but it's a little bit not so flat. That's okay. Coming in this tube, we've got air. Okay, you have air coming into the tube just from the outside, and it's being pumped. And as it goes, this is going to change. This oil level here is going to change. Okay, so you've got your air. This guy that I just is a very basic kind of clock face looking thing on my drawing. This is a pressure gauge. Okay, here and here we have oil, and oil here too. But up here we've got our, and this is important because this is the part that makes Boyle's law work, it's the fixed mass of gas. Okay, that's about all we need for our label diagram. Like I said, there are variations and there's lots of different ones. So if you're looking at yours and looking at mine and saying, oh, I have something extra or I'm missing something and you're not sure, you can let me know. But that will do the job. That'll get your marks. Again, if you're also not sure, you can look at the marking scheme and see what they were looking for that year. But I will say that I'm always a little bit cautious of marking schemes because they can change from year to year. So this year they might have given you full marks for this, and another year they might have expected a little less or a little more. It depends. So just, if you're using the marking schemes, just be cautious that you're not relying on them too heavily. Okay. We'll do part 3 now. Why is it necessary for the column of air to have a uniform diameter? And like I said, this is the thinking ones for the people that they're wondering, are you thinking why? Instead of just reading the question going, okay, yeah, uniform diameter, great. Well, why? Now, we kind of do these things in practice anyway. You wouldn't really have a column that was all uneven. So what they mean there is that this column, my not so wonderfully drawn column here, you know, we drew it on our diagram there, but it's really like, it's a cylindrical kind of guy. It's going to have some diameter. I'm drawing kind of a version of it here just to show you this is not part of the question or your answer really. It's just to give you an idea of what they're talking about, just to show kind of a tube situation so you know what they mean. It's usually glass, so it makes sense. You could have your see-through tube there, something like this, and they're asking you, why do I have one with a uniform diameter? Meaning, why do I have it so that no matter which point on the tube that I were to look at. If I looked here, it'd have the same diameter. It's probably pretty skinny. It might be a centimeter or two. And if I looked up here, it would be as well. Okay, why does that matter? If I had a tube that was all variable, what kind of problems would that cause? Okay, I'll shove this down a bit because this is really for part 3. You know what I'm talking about. Now I have a texty explanation from my sample answer, which I'm going to paste in here, and then we'll have a look and make sure that it is making sense to us. And obviously, as usual, if not, let me know. I feel like you could probably answer this with a bit less text, and that would be fine. I'm just going to give as much explanation as I can to help us all understand why it's important. Okay. These are the kind of answers that when you look at the marking scheme, it can be a bit hard to know how much or how little they wanted. So here's just an idea what you could have answered, all right? Now, so this is a reminder, I'm only, the first sentence here, I'm just repeating back what was given to me in the exam paper, and I'm just trying to get myself grounded. What am I talking about? So in this experiment, the length L of a column of air of fixed mass and uniform diameter was measured. Okay, that's just what they told me, but the important part here is the uniform diameter. If we're trying to verify Boyle's law, which we are, the volume is required. So all up here, we're talking about pressure and volume. When we stated Boyle's law, we're talking about pressure and volume. But when our student went off and did their experiment, they were talking about length. But they did say that their column had uniform diameter. So you need to, if you want to get to the volume, you need to make sure it has a uniform diameter. So this is how he explained. In order to verify Boyle's law, the volume is required. So you need volume because you're talking about pressure and volume, and we don't have it directly. So it's necessary for the column of air to have a uniform diameter so that the volume is proportional to the length of the gas in the column. That's really the answer part there, okay? That little bit, I'm going to highlight it a little bit. It's necessary for the column of air to have a uniform diameter so that the volume is proportional to the length of gas in the column. That's kind of the crux of it. And then we know that the volume could be calculated from the length when the column diameter is known and uniform. So if someone came along here and said, this is a 2 centimeter diameter, you could take out your length and it would just be back to your kind of log tables and volume of a cylinder, and you could work out the volume that way. We don't have to do that for this question, but just in theory, to know the volume, you need to have a set diameter, because otherwise your length measurement wouldn't really mean anything. If this was like, I don't know, a Coca-Cola bottle, how high up on the Coke bottle I am is irrelevant because I can't work it out easily like I could for a plain uniform cylinder. I hope you're with me with that. If not, let me know. So just to recap it, because these explaining ones can be a bit tricky. So the student measured the length of a column of air, but the cylinder was uniform diameter. We want the volume because we're trying to verify Boyle's law. And in order to get the volume, we need to have that uniform diameter because otherwise the length is meaningless. So it's necessary for the column of air to have a uniform diameter so that the volume can be proportional to the length of gas in the column. So it will be, if I have a lovely neat cylinder like I have over here, as the oil level or air level changes, kind of creases up the column, every step of extra length I have is proportional to extra volume, okay? Whereas that's not true if it's not a nice straight cylinder, nice uniform cylinder like that, okay? The volume can be calculated from the length when the column diameter is known and uniform. And here's the kind of like part that I'm getting at. In short, volume is proportional to length. That's only true if the cylinder is uniform, okay? Okay, I think I've said enough about it, but if it's still not clear, do let me know. And yeah, that's basically what we're getting at. Having that uniform cylinder means that I can say that this is true. I can claim that my length and my volume are proportional, okay? I don't think that was that well answered that year, so see if you feel that you are comfortable to repeat something like that if it came up again, okay? All right. the next part is a little bit more standard fare of experiment questions. We are being asked to draw a suitable graph to verify Boyle's law. Correct. I'm going to give this a little bit more space. We're going to have to do a little bit of calculating on our data, and that's just fine. But we need to have a little space for it. So we have the idea from Boyle's law that pressure is proportional to 1 over volume, but we don't have volume in this question. So typically we would say, we would be thinking my graph might look like this. Pressure is 1 over volume, and you'd hope that you get a straight line through the origin to verify Boyle's law, because that shows proportionality, and that's what we're looking for. We don't have volume, but we have length. So this is what we're going to do. We're going to do 1 over length and hope that we end up with this as well. These little kind of small sketches of graphs, I find them really handy, and you can absolutely throw that down on your answer book, and it'll at least show your examiner that you're going in the right direction, and it'll remind you to what you're kind of aiming for. So this is not an option for us right now. We're not able to do it, even though it's our standard one. So here's what we're interested in. By the way, you could also do either L is something like L is proportional to 1 over P either. And you're showing the same thing. You're kind of trying to get that inverse proportionality. It doesn't actually matter if you did it that way, that would be fine too. I'm just going to stick to this one because it's a bit more like our usual Boyle's law graph, okay? It might be more like something that you've done before. So I'm going to take my data table, and just because I have the ability to copy and paste here, it can be a little bit easier about it. And I'm going to bring it down because we need to do a bit of work. In your answer book, you could copy in the table, or you could just do your calculations separately. I would definitely have the calculation that we're about to do in your answer book rather than writing it on your script, your exam paper, your paper, because if you make a mistake later on, at least it can be shown that you had the right idea. And obviously you're not going to be able to do this kind of stuff that I'm doing, but you know, you can show however you like what we're about to do next, okay? I'm just doing a little bit of boxes and things like that to make it easier for myself. We'll do the rest by hand. Great. Okay, so I've just said there, just remind ourselves again, what are we aiming for? We are looking for this kind of graph. Okay, here's what we want. We have pressure. It's here. It's as it is. We don't need to do anything to it. We're happy with that. But it's no good for us to plot just length. We need that inverse proportionality. So we need to go 1 over length, and our units are going to be centimeters to the -1. My minus is not coming up great. Okay, right. So I'm going to have to do a calculation. I literally in my calculator will be writing 1 divided by 15, 1 divided by 20, 25, 30, 35, 40, etc. Okay. And that's going to give me the kind of graph that I'm hoping for. So I'm going to do it, and I'll fill in my answers here into this text box. I have it done already, so I'm just going to fill them in, and you can obviously, if you want to, just check. If you're thinking, I'm not sure what she's talking about, I'm not sure I get how I do that in my calculator, pause it now, give it a go 1 divided by 15, 1 divided by 20, and so on. And then when you play the video again, you'll be able to check immediately if you got the right answer, because I'm just about to write them in now. Okay. We're going to have lots of zeros. My decimal point doesn't work great on this pen, and no, 0.0067. Here you go. 0.005. Sorry, 0.05. Okay. 0. You have to like scribble 0 or 0, 0.030. And I'm on purpose keeping these zeros because I'll come back to that in a second when I'm doing my graph. Oh, I made a mistake copying something down. I should have 33 and 0.029, 0.025. Okay, so just make sure you're getting those with the inverse. Sorry that my decimal points are just very messy looking. So I've got the reason I wanted to leave those zeros, okay, it's going to make it easier for me when I go to plot my graph, because I will be able to kind of look at the significant figures, and we can talk, I'll say this again in the graph, but if you're not sure what I mean by significant figures, we can delve into that separately. But for the moment, for the purpose of this graph, what I mean by that is I can kind of ignore these initial zeros, these first zeros, and just look and go, I have a 67, I have a 40, I have a 25. And when I go to the graph, that's going to be much easier than trying to handle lots of decimal points on my graph paper, okay? And that's why I very much on purpose said 0.050, 0.040, so that I have the right number of digits in all of my data points, just to make things similar and really easy for myself. Okay. Hopefully it's making sense so far. If there's something that isn't just now, it's a good time to ask. And it's going to be hard to do your graph if you're not with me so far. But what I'm going to do next is we'll jump over to my graph paper. I'm going to plot that graph out in as much detail as I can, because I'm trying to accommodate a lot of different abilities where you might be kind of early in 5th year and your graphs might still be very scary, because there's a lot of thinking to go into a graph, or you could be a 6th year or 5th or 6th year, either for both cases, but you might be really confident with your graphs. You might love doing them, and you might be able to kind of do them almost like fluently, automatically. If that's you, you could just jump ahead in the video and have a look and see if your graph looks a lot like this graph. You know, I'm going to make the assumption that you're getting the best out of these videos and you have a full sample answer done for yourself. Check your graph against that. Or just I'll have a sample answer linked to this video too, and you can just go look in the sample answer, look at that graph and compare it to yours and make sure there's nothing too different that you're concerned about, okay? Because I will try to give as much detail as I can to make sure that everyone's able to follow us along. Okay, great. So we're going to take a pause. We'll have a look at the graph paper, and then we'll come back for those last couple of parts where they're asking us to explain how our graph verifies Boyle's law, and there's a few questions as well about an inconsistent data point, which is a bit of a hint for your graph as well. All right, we'll catch up with you after the graph. So